colleague Melanchina here, and he is going to introduce Ruben.
So I would like to introduce next speaker, Ruben Rabaneda Bueno. He actually came from Spain to our group, and he is data analyst in our group dealing with this spatial data, telemetry data we are using, and he is good at application GAN models and visualization of GAN models. So we asked him to introduce this gratia package done by Gavin Simpson, and because Ruben is here and Gavin Simpson is in Canada or in Denmark, is that so it was easier to ask Ruben. So I hope that it will be useful for you to see how to nicely present your telemetry work and make nice graphs. So
okay, thank you, Mila.
Stage is yours.
Thank you all. Okay. So this is going to be an introduction of to this package for GAN visualization that Eric already introduced yesterday with a lot of complexity, but very good. This introduction to the package doesn't include only this library, but I'm going to try to do an overview of other libraries because I think it is interesting just to not only compare but also just to have an idea of what other tools you have available for presenting GAN models for publication, for papers. So let's go through the contents. So I will go, I want to because there are a lot of material, I think, but I wanted to tell you that the presentation is in PDF, so you can download and follow directly in your computer. But also, I have added a link for the GitHub contents of the course in a GitHub repository, so you can access directly there. This is a more oriented base code for following the course. I think it is interesting if you want to copy, for example, code from this GitHub page to the RStudio while you are following the lecture. Also, I want to know that the content of the course in the repository are slightly different from this presentation, but just minor difference because of the schema at the moment of preparing. So, but you can access them, all the contents, clicking in the links that are in the index at the top of the page. So we will go also through preparing the data. So in the end of the presentation, or more or less in the last half an hour, I hope, I don't know, I will try to just do some examples of practical examples of exercise using this package. So the idea is just to you can do it by yourself, copying the code, or just trying to think which are the different functions that are going between each of the script codes, no? Just to have an idea, or at least say, okay, I have the real data, I have the real GAN models objects, and I'm plotting them. But also thinking in how to convert from one package and another package. But we will see this later. So the contents go through this. First, I will introduce a bit the preparation. I think I have commented this before, so I can skip this slide. But just one idea for this GitHub repository presentation is just that you can contribute also to the contents of it. So you can make changes or commit to commits. I don't know if you have any idea of GitHub, but it's very helpful for analysts or data scientists. So you can work the code, put your code there, then you can just suggest commits or errors that you can find in the different chunks of the code or whatever, or add explanation, add new plots, suggestion. So this is a very interesting tool. I would recommend all of you. So I will this I have made it publicly, so you can access it whatever you want at any time. My idea is just to make it like a small project for future. So I will keep it updating because visualization of GAN models is not It looks easy, but in the end it has a lot of details, a lot of tips that you have to take care, no? And also there are many things that I cannot cover in this presentation. So I will try to cover the most important thing and just have an overview. So all of the most important contents and functions. Okay, so here we have the RStudio dataset. You can start loading the libraries, tidyverse, Zoom, data table, and then I uploaded the dataset of 3 species that are 3 fish species from a reservoir area in Czech Republic. So this is a sample only because we have a data set for 1 year, but I reduced to at least almost 3 months. So this is just too easy computation, just in case we want to fit another model, for example, another GAN model. So once we have here, well, we can see the contents, no, of this data set with different variables. We have a piece ID that we will use for fitting a model with random effects, random intercepts. We have a species group variable that we will use for GAN models just to fit different models of by variables, so factor smoothing variables, or even tensor surface, spline tensor products, smooth, including this grouping variable. This is next section. So we have the different dates, the time series of these species and individuals. And I have created different columns for seasonality. So we have basically just 3 months. So we could consider that the trends are monthly. So we have the trends from 1 month to second month to third month. But then within each month, we can have some within seasonality. So for example, weekly seasonality, we can have daily seasonality. So this, I included this column because you can play with this data. So after the course, or well, you are working with the course, with the lecture, sorry, you can see all these possibilities. Okay, and season, we have different variables. Season, we have code as factor and so on. And two variables, covariates, that are BL, that means or refers to body length of the fish and the temperature of the water. The fitted GAN models are all mixed. We could say, as Eric already explained yesterday, that we have a linear regression model, but in this case we have a non-linear relationship between the I response and the covariates or the X variable. So the predictor variables. In this case, we can have a nonlinear relationship, but it could be possible that we don't have any. We have to assess this. I think I'm not going to include this process because it's quite complex. We have to look at different parameters, functions, like well, now I'm forgetting GAN check is a function from the main mgcv package. And then just try different nodes. So passive function, the number of passive function is going to check the slope of the spline, no, of the trend. So I don't want to go through this because this could take only just a whole course, a whole lecture. So maybe for another workshop, or just when I update the contents and include this information in the GitHub repository. Here we have three models. One model fitted with the cubic spline, smooth. We have these models. I have, to be honest, I just wanted it to work. So just to show you that really I haven't assessed them. So probably they have overfitting. They have incorrect cubic spline function because for example, here I didn't specify the cubic spline. The nuts number, for example, if we have 10 series, we can have, and we include cubic spline in theory, could be wrong because we are mixing, for example, January to March, connecting both. If we are connecting this, the M and the star shouldn't be correct because February is different at January, is in different season. So this could be more same, for example, between January and January next year. In this case, I would include a cubic spline, spline with, for example, 12 nodes, no? And just trying even more, I don't know. So this is another process. I won't go through this, but also these models include the correlation, autocorrelation structure of further group. So we have that the time series having the different estimates, different points, but the different points are correlated between them. If we want to estimate some effects of some predictor through the curve, to the trend, we cannot assess since we have not accounted for the independence of the observations. So we have included this autocorrelation structure there. We see also here the this idea, as I said before, is the random effects is the equivalent of the linear random intercept. So it's a Fish intercept. It's something similar, not exactly the same, but we could say that it's like that. So this could be a random effects model with a random intercept, but this doesn't include a random slope. So we have a by-species variable. So this is a factor smooth. It's like an interaction between time and species in a linear regression. It's like just x, so time, x, species. But in this case, what it fits is different non-linear spline trends for each of the level of the grouping variable, the by-species. So the others are just variation derivation of this first model, the main, which we on which we will base this lecture and the different functions of gratia. Sorry?
Ask a quick question. Does core ARMA work within the BAM framework?
Yes, it's work. It works?
Yeah, core ARMA didn't think it was integrated within BAM, only with GAM.
I think I have obtained results. I use sometimes it's package, just using a starting index. But I have written different mgcv packages that works, and actually this works. So, but probably this is not, as I said before, I haven't taken the time to check all this thing. No, just I wanted to fit the model, so it is a blocker model object. And then from there, just to start working. But this is not my task now. So probably this should have errors, no, in this regards, in the part of the autocorrelation, the residual autocorrelation. But okay, I don't want to spend a bit more on the explanation of this of the models. But basically, the next models are the derivatives of the first model. So. We have a second model, includes a different spline function. This in this case is a thin spline regression spline. And then we have a second model with a thin plate also, but we have this idea and we have an interaction, one-dimensional interaction, multidimensional, between two variables and grouped by the factor smoothing, so by species. The other three models include tensor spline. So we have a TE, we have a TE parameter or TE function just to fit an interaction between the two covariates that are continuous, body length and temperature. And also we fit this interaction for each species. So one slope for each species, for each grouping variable, for each level of the grouping variable. In this case, we don't include, for example, random the partial effects of the body length and temperature, because we should include another function like TI, if I remember. Okay, so I will go through the next model, which is a model with factor smooth interaction that include a BSFS. BSFS is indicating an interacting FS object. So this is like factor smooth interaction. So it's like just take the fish ID, for example, and fit a slope for each phase ID. So phase ID, in this model we have that. This is indicating, no, this, yes, okay, here I don't include the random intercepts like in the previous model, but it is included in the factor smooth. So this should be like a similar, quite close to a random slope intercept model, no, in linear regression. So in the next model, the last model is a model with fitted with a different function for some purpose. I will explain later. And this also includes some timers pipeline just to filter the species that we want. Just to, so this is a model fitted only to the pipe capacity. Okay, some useful tools that are useful when analyzing and visualizing the models are these two libraries, Itsadu and Ceske Plot, and function that model are GAMTABs that probably you have used before, and you can export in HFM tables or other formats also. So this is just a suggestion you can use. So let's start for visualizing the visualization of GAM models with the package mgcv. The package mgcv is basically the main package, R package, and the main function is the plot GAM function that is based on a base graph. So in this function, for example, we have that we include the model. In this case, the first model mod. We didn't specify any parameter or any smooth term, so we choose every one and just we plot the model. So the different trends, the different slopes for each of the species. We have, if you remember, we have time fitted by variable. So the level of the by variable species is plotted for each one. So one trend for each one. We see here that the trend, there is no much change. We should probably evaluate further if this is a significant trend or not. And then we can, in another species, I think it's pipe fair. You see here, it seems that in this point there is an increase, no? An increase in the smooth in the smoothing trend, no? of the time variable. So it is the same. Sorry.
Ruben, we have a question from Mauricio.
Yes.
Yes, it's just technical question,
Yes.
request. If you could direct the voice to the microphone, since there is a huge environment noise around the microphone. I don't know why.
It's because I can put this in the chair maybe.
Thank you. Sorry for interrupting.
No problem.
What
Here.
about just here?
Oh, here. This is this computer is as you see is a brick. It's very heavy and it has a strong Wi-Fi connection in the screen. So probably this is the issue. Okay. So
Thank you again.
yes, no problem.
That was Mauricio.
Yes.
There is probably interference between Ruben's.
So we see here that the model fitted before, you remember this the three levels, and we see also here the random effects, no, the Gaussian quantities of the random intercept that we fitted with the BS RI per E variable or parameter. Sorry, it's not working. The function, this GAM, is another function, is an interesting function from this mgcv package, and can be used to plot the smooth effects of a smooth effect. So in this case, we include that the additive is like including the random effects in the visualization of the model. This is based in the model prediction of the model. So, okay, and you see here a 3D representation of this model where you have different covariates, temperature and body length, and the increase or the decrease in the so the interaction between them. But we can also plot this in terms of 2D smooth surface. In this case, for example, we have the option here to plot type of contour. If we change this to contour, we pass from this to this. So I wanted to put here as an example, just you want to play with the code and just change. And then there are different customization parameters like setting the different angles, changing the resolution. For example, if with Ungrid, we have the resolution is good, but if we increase it could be even better. So we can see here less smoothness and better definition. Another interesting package that is based in mgcv is this mgcv. So it's quite similar, but it's different. We have functions that are connected or are related to the mgcv. And the advantage of this package is that includes option just to combine with ggplot themes. So it's quite handy with this ggplot library. And for example, here we plot to plot a model. We first need to get information from the model. We get the function, then plot the model. We should select the model terms with select. In this case, we didn't select anything. And draw, this is an option, just to draw a horizontal line, and we see this the smooth effect of each of the variates. So it's quite similar to the mgcv, but with some difference, and we can further customize or personalize these plots, like including different parameters like the fitted points to scale the trends. We have the fit contour function just to fit contours that I haven't put it here. Or just this is not because we don't have here an interaction, but anyway, I have included this. I have defined before in the previous slides that probably I didn't comment. Is some ggplot themes. So this is the TSD2 is one ggplot theme I personalize, I customize. So you can log from them, but you can choose any other for changing the font size of the axes, the values, etc. Okay, here we see that plotting this with this bit mode that we extracted with the function bit, we see also the trend of the different variables. So it's similar, but we can adjust different things. Plot and bit can also be used to select the smooth term of the grouping variable with SM. We have here. Sorry. We can combine, for example, in this case, we do for the model 2 with the bit, and then we use plot, but just calling the function SM. With the SM function, we can also select the different smooth. For example, in this case, we select the smooth third, in the third position of the object. So this is for width. The second is for pi pair, and the first one is for pi. And then we can use the grid pref function just to combine the plots. So in this case, for example, you can see that we combine both model objects from model 1 and model 2 with different ggplot terms. And also we can further extend, just adding, for example, customization with the arrange group function. So with grid and grid extra, we can load these libraries and use them with the mgcv objects. So you see that there are options for customization with the ggplot using this library. Another option of functions are the dense, that is just for plotting the conditional density of the residuals of the predictor variables, the smoothing variables. For example, like this. We see in this case, for one of the models, we have wells and piper in this case. So that is showing that basically the same density through the line. Just at least in piper, but not in wells. But here we have at 0, and at this time we have less density of points, no, of the conditional probability between the response and the variable. Another package I would like to introduce is Isadut. Isadut is interesting package for other kind of representation, but the thing is, it is based on our graphs, and you see here, for example, that is not very it's not looking very good for publications or whatever. So it is a lot of further customization management, and you end up just becoming crazy, just trying to obtain good plots, no, nice looking plots. But anyway, I wanted to introduce a bit, and just because it includes some functions that are quite interesting. So here we plot again the same model with the different species, the bifactor variable. So
if you can go back just one slide.
Yeah.
Under the hood, is this just generating the predicted values from the model?
Where?
On the y-axis, are these the model predictions?
This is plotting the smooth effects. So it is the partial effect of each of the smooth covariates.
Yeah.
I think this is not based on model predictions.
Okay.
But I'm not sure. So each library package include different approach. So sometimes it's difficult just to be clear about this. That you have to go to the mgcv, Isadut, whichever manuals or package of the gram mirror site of the package, and just check for this, because maybe I can include this option. But in this case, I think it's partial effects of the smooth covariates. But I cannot be totally sure.
Yeah, there's like 3 main ways, I guess, to visualize the GAMs, like the predictions from the model, and then the way that like the default plot GAM function in mgcv works, where it plots it relative to 0.
Yes.
And then partial effects. Do you have any comment on what you prefer?
I think we should go further, because I think the best, at least for best representation, I'm just choosing the different options. For example, partial effects, residuals is just going to gratia. I wanted to introduce this a bit later. And just one example for this package is just including this, for example, is a customization using Isadut, but you see that it's a bit cumbersome. No? Just to start working on this. And even if you can use some loop function, for example, just to call the model and then just select between the different, for example, in this case, grouping variables, you can create a list and then just run a for loop. But then it is a bit and further you need to customize this plot. So it's a bit cumbersome, as I say. This package also includes one library for one function that is that allows the possibility just to include layers, no? So to the plot, because the original function doesn't include this option. So this is because I wanted to go to the gratia page to start to the Isadut package. Is this function that allows to plotting the symmetry effects of the random intercept. Like we see here, the random intercept is included with the main smooth effect. So it is plotting the confidence intervals, but including the random effects and the average effects of the smooth covariates. And this is probably the most handy function from this package that is plot diff and plot diff2. We can use this function just to plot, for example, the species, a variety of species difference. So if we have, for example, 5 and 5 per trends, we have obtained the curves, no? We have evaluated the fitted spline of each of these levels of species, but we don't know how the different they are. So we can obtain a smooth surface or a smooth spline of this difference between pairs of the grouping variables. So in this case, we plot pi by pair, we plot pi west, and we plot by pair and well. So the difference between them is shown here with a significant difference where it is occurring the significant difference. In this case, between these points, so 17,340 and this red. So the area inside the red line, the square line, the red square. In this case, for example, we see that there are significant difference between pi pair and wells in this period and in this period. So there are two periods of a significant difference. In this case also, this is more stretched in the case of pike and wells. And in the first case, pike and pi pair, we have only a significant period of difference. So this is we can call the difference smooth, no? Between each pair of levels of the factor by variable. Sorry. So continuing with this package, probably a bit is just this another function that is similar, but it plot difference in different way. For example, in this case, if we include the pi variable, we can this plot diff2 function is the con parameter is used instead of con. So we can see that the personalization is different, but we finally obtain, for example, the effects of the 2D surface effects between the temperature and body length that are the covariates, for example, in the tensor spline smooth model. We have the model with the tensor spline. We have these covariates, body length and temperature, and we have the different surface between them. So this is to compare an interaction or just the relationship between two covariates between each pair of the grouping variable. Okay, and now let's introduce to gratia. That is a package, just as the name says, is an R library developed by optimization that already I introduced yesterday and has been already told, and you know. So the best way just to announce, and I explain this. I wanted to go through these functions because apart from the function currently included in the graphic page, there are some others that are not actually functional in the package, are not included. So you need to download separately. They are deprecated function, but I think they are quite useful for what we want to see later. So I would encourage you just to download with the script I provide, with the just loading the library cool library, and then just downloading these functions. Here is you can access also the repository of Camille Simpson. It has a lot of useful information about this visualization of the model with gratia and other functions. So one of the advantage of this package is that it is based on the ggplot system, so ledger system. So you can customize a lot of things. It is very straightforward, just very easy, just to define different terms. For example, like this one, I have defined before For other plots, the T is 2, but I think that I confused something here, so this is going before just. But anyway, so we have two terms, for example, that we will be using, and then we have a palette of colors that we can define whichever you want from the base color graphs, color scales, and for example, here we have model diagnostics using the histogram of the model residual. So just with the function residual is plot, we can plot the model depiction residual in this case, but we can change to deviance and response. So in this case, we can also add a title, we can add a subtitle, but we haven't customized further. So we have only this base gratia plot. Then we can add further customization or personalization, just including, for example, a term like the previously defined TH1. For the others, I will use also these already created terms. For example, for this one, that is just another function just to model, to assess the model diagnostic residual in plot that show this linear predictor versus the deviance residuals. It is already customized with these color palettes, with this just transparency, point alpha is indicating the transparency, and the deviance is the type of the residuals plotted. Okay. Now this is also the quantity of model residuals. It's another function, another possibility just to assess with the QQ plot with different options. We have the default method that is running for, which is the randomization. Then we have simulate, and we have uniform. So we can also customize. We see that the model is not doesn't look very good, but it's okay just to show you. And just another function is observed fitted plot. So just to plot the response versus the fitted values, and just you can do just basically you apply the appraise function that contains all the model diagnostic plots. So the plot of residuals, the residual versus linear predictor, and all the others, all the histogram. Another helpful useful function is the Rootogram of model diagnostic. Is used to assess the goodness of fit of the model. This is based on a paper of Wales and Thales, the base, no? And this is basically you can choose the type with standing, hanging, etc. But it is recommended to use hanging. I have used standing here, but hanging you can see the expected response that in the blue fitted line. So the histograms or the bar will be hanging from the expected line. This is used to assess different counts of the continuous variable, the discrete variable, depending on the on whether the bar are reaching the zero line or not. So if they are above the line, on the zero line, it is indicating that it's overfitting, and if it is down the line, it is indicating underfitting of the model. So this is an interesting tool just to use with gratia. Then for just the main function of gratia is the draw function, is the one that is used the most. And this is can be combined with ggplot, and with a lot of possibilities, almost endless for customization. So in this case, for example, we are going to plot the model mode, the model number one, with different options. In this case, for example, we see that we can plot all estimates. We can select them. The second is like seen before. Residuals, we can select the scale. If for different plots, for example, for the Ruben variable, we want to have the I-axis in the same value, in the same scale, between pi, pair, and wells, and so on. So we have here, for example, TH2 LGD plot 10, just for better, for nice representation. And here we have a similar visualization as with the mgcv plot. It's quite similar in the end, but the thing is that we are going to further, we can have further customize this plot just to present them better. But also these are already customized with this TH2 GG plot 10. Here we see the quantities of the smoothing function for the random effects with the VCRE parameter spline, and then with the parameter select we can choose, as I said before. Okay. Here then is a parameter quite used through the different draw function, the gratia functions, is used to evaluate the smooth of covariates through a range of the values, so the different values of the covariates. We can see if the smooth is going up, is going down, is changing the shape, and so on. Smooth allows the selection of the smooth term of the model to be evaluated. Is like similar to the term and select function of other libraries like Ilsaduc, mgcv, where we use different parameters for selecting the smooth term. So here we have one example of this evaluation of the smooth term of the time covariate with the first one. In this case, we choose the partial match true to match the smoothings, and we have we choose this time variable, the time smoothing covariate. This is one I want to show you this because as we saw before, for example in this plot and the previous plot from the other package for visualization of terms, is that we already have the time in an integer format. So you can see the numbers here because we have to code as integer because otherwise we couldn't fit the model. As daytime, only at least I've not been able to do it for the main smooth effects, but yes, I could do for the autocorrelation structure. So with this script, this code, I can change the time to date format. From here, then we can draw. So just using TDverse, we take the object created with the smooth estimates, and then with the draw function we plot it, adding GB plot. So we have here the chain with the x-axis. We have now a proper time variable, at least more indicative than the others. Another interesting function or just application of this package is just for plotting the random effects, the smooth effects. So we have fitted before a model FS that includes an interaction between one covariate and then just a different slope for each of the covariate. So for each piece we fit a slope and an interval. So we want to plot this. To plot this, we use the draw function the same way. The thing is that the result is going to be different. In this case, we are selecting only from all the plots possible. We are plotting the fixed ID interaction with the EL. So we are plotting the random slope of each body length for each piece. In this case, we are plotting the random slope of each fish and for temperature. And in this case, the main effects are average effects of body length and temperature. So if we include, we don't select here, we just choose null or select null, we are going to obtain all the plots. For here I have, I don't remember now the model, it includes by grouping variables, so we should have also the main effects or the average effects of body length and temperature for each of the species. Apart from the random effects, so the Gaussian quantities of the random effect, the random interface. So we will have the random slopes and we will, apart, we should have also the random interface for each piece. It is interesting for models fitted with dimensional splines. Tensor product smooth. If the model contains a smooth surface due to the interaction, as before between, for example, covariate 1 and covariate 2, draw generates to the use of this. So we see here that we have a contour plot, in this case, with temperature in this in the x-axis, then with number in the y-axis, and we can evaluate so the change in temperature through the different weeks of the within each month every week. So it is an average effect through the within weeks through the 3 months. This is an interaction between this variable and the week number. So it is fitting different different slope for each of the species also, because we included by variable. Okay, the contour plot also I didn't mention. This just shows the effects of the response at different values of the temperature, covariate, and the week number. Also for fitting fitting models with tensor splines with the TE function or TI or T2, as I said before, we can, when we use the draw function, we visualize the interacting splines. So we are showing here this in this case with different color plot, color scheme, the BR and the temperature on the axis and the effects of the response. So different gradients, color gradients. But this is a different for a different model because before it was for no, this is the same. Yes, this is the model with TPS. So it includes one interaction, but it doesn't include a tensor spline. So a 3D dimensional spline surface. So with another function interesting for included in this package is the posterior for posterior smooth drawing from the table table. So the smooth sample basically what it does is just create a table table containing draws of the posterior distribution of each smooth in the model. This is, for me, it is the most interesting aspect, the most interesting feature of this package, creative package. It is because we have from the different function we obtain a data frame. In this case, it's a very clean table that we then can convert to data frame or whichever format we want, and we can manipulate even just further analyze this data. Just work with this. Just transform whatever you want. You want to transform the variable, but also we can plot obviously the ggplot terms, so with better presentation, visualization. Like in this case, for example, we convert the one of the terms that is created with the pivot table, the x1, we convert to date form, so we can plot them with ggplot. In this case, so once we have created with the smooth sample function, we have created the smooth sample. We can say the object. We can then draw. It's very simple function. So we have created first this object, then plot, and we can customize as always using the color palettes, the samples, etc. So the sample sets the number of random the sample draws to display. So if we increase the number of samples, we are going to have for here thicker lines, so more close together. So it is going to be more blue in these areas of each of the grouping variable. In this case, for a species, 5 can prepare for time covariate. So and also it is interesting because we have already this object or object table object that we can use for analysis, just having this posterior smooth. So another function is the comparison function. It's very interesting because it serves just to compare two models, for example, model 1 and model 2. And model 1, for example, is one is the same as model 2, but fitted with different spline functions. As we said before, the model 1 is fitted with the cubic spline function, and the model 2 is fitted with thin plate spline. So we want to compare how the curves of each of the covariates differ. We use this function, comparison. In this case, we also obtain a pivot table that we can use for whichever you want, for further analysis or whatever. But yes, we are interested here just creating a for loop operation functions, compare, for example, first piece ID, that is the individual intercept, to factor. Even if we have already converted, you can include these options because it's very flexible, this gratia. And so from here, we can draw. We draw the different smooth functions, the different smooth covariates between the model 1 and model 2. So there are a slight difference between them using cubic spline and thin plate spline. In this case, for example, there are more for pi, probably. If it is the model 1, the red color, this is pi, this is just model 1. And second is, it looks like a parametric term. So probably, as we saw before, the curve, we were not sure if this is probably a nonlinear relationship for pi. Probably it should be fitted as a parametric term, so without including a smoothing function. So it is another topic, another for as I said before, evaluating all these things for fitting after fitting the models. But this is an interesting tool that you can work on it and just to compare models fitted with different spline functions. Another function another function is the for this different smooth can be used to compare the smoothing curve of for example level of the by factor variable, the factor smoothing variable. We have not the factor smoothing but the by variable, so the grouping variable. In this case, for example, we use different smooth for model 1 with a spline expansion for time. We also convert to take time format, and we can see the pivot table of the smooth difference. This is different function, different smooth to compare smooth. To compare smooth is just to compare models with different fitted spline functions. So the same covariate, the same smooth term, but with different basis function. Either regression splines, cubic spline, whichever. But this is for comparing the different. It's like the plot different, the plot diff function from the itself package, but with more functionalities as we have we see here to create, for example, a pivot table with the different smooth that we explained before for the itself package. We see here the difference with the standard error, the upper and lower confidence interval. So here we see the difference. Is to remember the previous different smooth surface plotted with the itself package. They are basically the similar plots. The only difference is that we don't have a square, red square, marking the period of significance, and we don't have also that daytime format, the x-axis. And this looks really much better for publication than the previous plot. But it's basically the same, so we calculate the difference. The thing is that one thing that doesn't include is the significance. As I say, it's the significant periods, so it is not marking the significant periods where the smooth is. So where the difference between the leaders of the grouping variable is significant. And it is showing only how they differ, but not at which point they differ. So we can do this, however, by extracting the estimated difference of the pair wave comparisons and the confidence interval information. For that, we can use the sigmif function that we already downloaded, and well, just I leave there. And now we will go through the penalty matrix of a smooth. Just is basically I'm going to very brief, just include this function that is penalty to extract the penalty matrix. So as Eric explained yesterday, but this would require more time. But the thing is that we have, as always, we can have a table of this penalty matrix. Just show them with heat map. So this is showing the different penalties. Penalties just applied to the basis functions, just to uncertainty of the smooth covariates. Here for is showing the diagonal the penalty matrix and so on. But we will go now through one more interesting concept, that is the derivatives of the smooth. Using the derivative, we can evaluate the gamma spline by identifying the pairs of significant change. So I don't know if you know something about this term, this concept. It's well explained in the gamma Simpson law, the here to the bottom to the here. From the bottom to the hip, I think is the name. And he has a paper where he applied this approach that is quite useful for identifying periods of significant change. We also use for a paper recently that is in review to estimate the smooth trends. So the smooth trend of covariates, trend covariates for different species of fish. But basically, we have a fitted line, a spline function of each covariate. So we have a trend, and we don't know, for example, in this case, okay, I will go further later. Here, for example, we can choose with the derivatives function. I'm going to calculate, or we are going to estimate this derivative, the first derivatives of the different covariate functions. So we can choose the type of the finite difference method, central, forward, or backward, and the result is a table that contains these derivatives of the spline function, of the spline, of the spline function. So then we can calculate the point-wise confidence intervals or simultaneous confidence intervals, credible intervals calculated from using Bayesian simulation. If the model includes factorial smoothing, you must specify the smooth on which to calculate the derivative with the term partial match set to true. For example, we see here the derivatives calculated for the model, the first model, more using the central finite difference selected with the type parameter. Then we have the third parameter indicating the smooth covariate, that is time, in this case, partial match, just to avoid different overlapping. And then we obtain a table with the derivatives of this covariate of the time trend. So we have we see here at different points the standard error, the derivatives, the critic value, statistics, and the lower and upper credible interval. So we see here the derivatives calculated for the different levels of the bigroup variable. So for pipe pair, and for wells, they differ, but we are not showing here where they change. So basically, if you have a model, a GAN model fitted with mgcv, we can see that when we use summary functions, we can have a covariate that shows significant effects. Probably the time covariate is significant, so the trend is significant. There is a non-linear relationship between the response variable and the X variable, so the predictor. The thing is that we don't know where this is occurring. So where the change in the spline is occurring. So we want to identify this rate of change through this spline function. To identify this rate of change, we need to calculate the first derivative. So the first derivative, what it does is we have one axis, y-axis, and we have different points through the curve. We are calculating the change in it with respect to the change in x. So with this rate of change, we are calculating the instantaneous rate of change. That is indicated the change in the brain in the figure. So I don't know if you have any question, because probably I'm going too fast or not explaining quite well.
Questions, guys? For Ruben?
Okay.
Anyone from the internet? Mauricio, everything okay?
Yes, this time yes. Thank you.
Displaying periods with significant change. So this, in this case, for example, is not possible with the derivative function. So we obtain the derivative, but we don't obtain where the change. So basically, this instantaneous rate of change. To do this, we can use this tabulated function that is already deprecated from the gratia package. That is very simultaneously that I put the code in GitHub and also in the presentation to download with cal download function. Is here, and we see we can plot and highlight the significant periods from the. As you see here, we selected for the derivatives of pi. Well, no. Now. Yes, is the derivative of pi. So this is used for a model fitted with the type dataset. Why? Because we cannot calculate these significant periods in models fitted with a factorial pi variable. So we need to subset the data, and after this, just you can plot the rate of change. So you can plot factor variables, the derivative of the factor variables, but you cannot plot or show this significant trend. This is for that I wanted to include this function, or even if it is not currently included, because it's very useful just to show where there are different significant increasing trends and decreasing trends. So we see here in red color that there is a significant decreasing trends in the slope, and we see here in these 3 points we see a significant increase. So a significant rate of change, positive rate of change. So after this, we are going to go through this calculating these derivatives, but also just to apply it for ggplot customization. How we obtain this plot, but in better format. So in this case, for example, we can use just calculate the slope of the derivatives. So the first derivative, that they are going to differ between species, just take one species, as we said before, and then just apply the simulations, the simulate function that we have already downloaded, and just plot it. So you will calculate the simultaneous credible intervals using the simulate functions. We obtain a table data set with these simulations. So it is the object of the pi derivatives and the simulation, calculated through the quantities of these quantities, and then apply the significant derivative functions just to obtain the periods of significant change. So this code is very helpful just to plot, to customize this significant rate of change, and is provided by Gary Simpson in his blog. Then we can have this transformation using the transformation of the given data set. We have this change in the upper level. The derivative is we choose the first derivative with this because this is a matrix object. We obtain, then we apply for the previous interval upper, lower, and then apply the. We include a change in the time format to the time, and then apply the significant increases, the significant FD function just to plot this significant value, or at least calculate it. I should have included this, but you can just visualize this pivot table, just applying this code and just running the hit or just visualizing this object. From there, just you can plot with ggplot2 and show the same plot, the same graph, but with a better customization and with the format and so on. Okay, let's go a bit to a practical that you can, yes, it's just to, if you can handle a bit with these functions and just work a bit, but you can just take the code from the GitHub content, for example, and just paste if you have any problem. It's not for stress. So, and always remember to use the diverse. That is good for this. Okay. Yes, I can now stop here and just connect RStudio.
Sure, no problem.
Do you have all of you have this for exercise? Okay, you can give a run to it and just work. Yes.
So the time is ticking, guys. Okay.
Just, I wanted you to, it's just an example, practical example for just in case you have any doubts, no? But I think it's very direct, no? It's straightforward, it's to understand, so just is it's also have 20 minutes, no, or something, or
These got, yeah, something like this, 25 minutes. Then I'm going to show the RStudio.
yes, okay. Okay. Okay, we have here the contents we can visualize with the res parameter.
Ruben, would it be possible to increase the fonts in your windows?
Yes. Okay. So?
Yes.
That's okay.
Oh, it's okay, guys. Can you see it? A bit more?
Yes.
Yeah.
Okay.
Why a little more? A bit more, Ruben, please.
So this okay. Here you can, if you have RStudio or R, you can directly go through this. It's just taking the code from the PDF or just taking the code from the GitHub repository or whichever. But I can just. Do you see everything or do you see all?
Guys, are you with Ruben? Everything okay? Yeah? Okay.
Okay, so again, we show this and we have different components here with different objects already created. And just we can go through exercise one that my idea was just you to practice a bit during this Vienna operation, but so it's, I don't think it's necessary just to go further. But here is the GitHub page. Okay. So you have here, for example, plot one of the exercise. Just plotting the partial residuals of the model 2.
Ruben, I'm sorry if you can zoom in a bit because it cannot be.
Zoom in. In.
Oh.
In.
Maybe a bit more.
In.
Yes.
This is the
Okay, so just this is very simple exercise just to color the smooth line, the residuals with color red and just using a classic plot them. So whichever you want, you can use MGW, I think classic or the one already created or one just one to create. Exercise 2, it just to plot the smooth time difference between bike and bike pair from the first model with confidence intervals to 90%. So here is just using a ggplot of them and mark the significant area of the smooth curve with a different color. So for doing this, just basically, as we say, it's just calculating the smooth difference with the different smooth with the smooth different function from gratia. From there, just extract the tibble table, and from there, just go to ggplot just to plot. It's just basically use different smooth for the model first model, then choose the time spline, with the CI level parameter, you can choose the confidence interval, the range. Then, for example, we can change the levels from character to factor for each level of the of level 1 and level 2. We can see here. No, it's not here. Okay. So here we have the tibble table with the smooth, the different smooth for each level, and just we are going to take and convert to factor for then select. So just for example, we use this one. Okay. And we see that level 1 and level 2 are character variables, so we cannot manipulate, or it's not very easy, and just convert to factor of them. Just do this. And we see here that they are already converted, and from here we can select. We select using the pipe of diverse. We can filter level 1, for example, for pipe, and level 2 for pipe pair. And the objective of this exercise was comparing both species, pipe and pipe pair. So we choose only this. We want another comparison. We can choose wells and pipe, or wells and pipe pair, or whichever. So then just create a data frame, a new data frame that includes the different smooth that is given by this. So the different smooth difference is indicated with this value, diff, and then the other variables time that we have already converted, but I think that we can include also here. Also the gradient interval upper and lower, the significance. Just we need to take this different and just apply using the lower and upper gradient interval to calculate evaluating this different with respect to the change from the zero value. So just this calculating whether if going up or going down from zero value is significant. So the difference is significant. So basically, it's just that. And then from there, just plot with ggplot as you want, using this already created data frame with ace function, choosing the time variable, and the different variable, John Ribbon, just to plot the smooth interval, periodic interval, and the start smooth with method GAM because we are using GAM basically. And so we can choose then the different color palettes and so on. So this is basically that. And we have the different smooth is you can check that is similar to the different smooth created with the plot if function in a Residuals package is the similar significant period, and is similar to the one created before for the with the gratia package, but that didn't include the significant period. So what we have done here is just calculating this significant period and plotting. And then the exercise 3 is very similar, but just using derivatives. The only difference is that here we need to apply, just calculate the derivatives with the derivatives function, filter in this case another kind of, okay, I'm going to show because I go fast and I'm not showing. Well, this is enough, but we can. On each line, it just basically plots the horizontal line through the zero value. So just to see where is the departure from zero, just to show the significance. So the values, the range of the spline or the periods where it's not included zero in the confidence interval is the significant period, and we see here. So if we want to include this just for visualization purpose, we can see with this. So this is not including zero, so this is indicating the significant period, the significant area for the fitted spline. So basically, this time spline was significant in the model, I think, because I haven't checked it. So it's significant, just here, but not for pi in this case. But yes, I'm going through the different concepts. Sorry, because this what I say is applied to the derivatives. It's the same. It's basically the same approach because we see that the significant periods is indicated by the area where it's not included the zero in the confidence interval. But this is for confidence interval. Then the same can be applied to derivatives. So just basically, in this case, we have the derivatives of a smooth of time for pi pair using the model first. And just plotting. And we see the derivative that is similar to the one obtained with the draw function. So this. With the derivative function. I think we can go better here just to show, because I have not applied correctly the function. So this one, no? Python. So I think, do you have any question?
Questions, guys? more questions. So there'll be an exercise for you, or it's some.
Yes, so
Yes.
I think I wanted to comment that there are other things like missing, because this includes a lot of, there are many possibilities, and with gratio itself, it has many things to comment for different parameters, inflation, calculation apart from the visualization topic. But also there are other packages that, such as this red, I couldn't include because it's not time for that. But this was quite interesting. You can also use ggplot with this, obtain prediction from the right function, and then from there just to plot the ggplot. So just perform some similar function, no, as gratia in that sense. But there are other functions inside the gratia package itself, as plot parametric, that is for floating parametric terms. So I haven't shown, but it's basically including a species. It is going to show the different the mean values, no, of the different grouping level variable if it is not smoothed, and so on. No? So that's all, and many others, but I couldn't cover all. So I think you have a question.
Okay, so Ruben, well, I can see no questions, so thank you very much for your time. Guys, I believe that was pretty much it. So thank you again for coming. I hope you have a great time here. And I would like to thank again our speakers and trainers for their time and
Thank you, all the organizers that have been.
yeah, sorry.
And I know there is too much effort invested in this.
Well, yeah, welcome.
Thank you.
Thank you very
For so I think we would have.
I know, Ruben, that your slot was the most turbulent because people have started to leave. So I'm sorry
Yes,
for that.
I'm sorry for because I didn't explain well. I have been sleeping very bad the last weeks. But so I try to do the best. But sorry if you didn't understand. If you have any question, or you can email or whichever. So I'm available. My email, I think I didn't include, but you can check in the EDM program. So it is there.
Yeah,
so
yeah,
if you want
yeah.
to theme and contribute also to the GitHub page, also
Yes,
it's be good.
You're doing a great job, Ruben. Thank you. Okay, and I think that we have Mauricio here. Go ahead, Mauricio.
Do my best. Thank you to everyone for everything.
Yeah, we are grateful you are there because you were probably, well, not probably, no, 100% the most active participant. Okay, thank you for having
Thank you
there.
for all the people also there in the remotely.
Okay, guys, let's go for lunch. Yeah, and Ina Provels and Renel express their highs and regards to you because they have to leave actually. Yeah. Okay, so let's go for lunch.